Oh no, what is going on? We have minus 20 amps outside. The battery is down to 14% state of charge only. Guys, welcome back to another video here from the Overkill garage, and look at this weather. I need to show you this. You need to have a look. Does it look like sunny hot Australia here? Huh? We had so much fog this morning. It was actually good. The system was charging with over 1 kilowatt this morning. The battery was down to 15-16%, and I decided to do this experiment today. So I turned off the solar charge controllers. They're all sitting on maintenance, what is it called, maintenance mode or something, so they are turned off. Even we have plenty of energy coming in this overcast situation here. But I want to really drive down the battery today because it's at 14% already. And I want to see what is happening with the 3 battery banks we have, and how the BMSs actually behave once the battery goes low and single battery banks will turn off due to some of the cells hitting 2.5 volts then, and the BMS will shut down the whole bank then. And I want to see what happens if we have a cascading shutdown of all 3 battery banks very quickly, or if the other 2 banks will sit there for another hour or so until they shut down. What is actually happening then? Because we have done the testing and charged all 3 battery banks to 100% state of charge, seeing what happens then when the BMS turns off, because we have single cells peaking. So we have experienced the full charge of the 3 battery banks already, and could see that the BMS is actually shut down a single battery bank if one cell is not balanced correctly and the voltage gets too high. It just disconnects one battery bank and then keeps charging the other 2 battery banks just fine. There was no issue at all. And I want to do the opposite test now to see what is going on in the low voltage disconnected situation. Now, I think it's important to know how your system performs at the top level when it's fully charged and at the very bottom level when it's fully discharged. So just you know what to expect if you're not at home and something happens. Is everything working as designed, as it should be? And this is what I want to do today. So I'm actually charging our dented battery cell here at the moment with the big charger. And I've got the pool pump running on a higher state, and I also have a cable running to the house. So we've got the pump and the washing machine running there. It's not doing much at the moment. But we are discharging with 21 amps here. So actually, let's have a quick look at all our BMSs and the battery banks. Start with the Overkill. This is not the Overkill. That is the Overkill. We are at 50.8 volts, minus 7 amps, discharging the battery bank at the top with 350 watts. And we've got a deviation here of 3 millivolts only. Look at this perfectly flat area of the curve. All the cells are nicely together at 3.17 volts. No issues here at all. Okay, let's have a look at the JK-BMS battery in the middle shelf. We're discharging with minus 5 amps, and we've got a deviation of 12 millivolt here and 3.17 volts as well. Okay, perfect. And let's have a look at the Heltec BMS in the bottom shelf. This is being discharged with, come on, connect, there we go, negative 6 amps, but we know this is a bit off, so it could be negative 8. And we can still see our cell number 15 here is our high voltage cell. This is the one we have just replaced. So it could be that this battery was actually higher charged than I was expecting, and we will see this one actually standing still there with a higher voltage than all the other ones. 40 millivolt deviation therefore, and this is only because of this replacement cell. But all the other cells are nicely at 3.17 volts as well, so no problem at all. Yeah, we are here at perfect 14% state of charge of all 3 battery banks, discharging with 1 kilowatt. And I would say we are coming back when we are at 10% state of charge. I will monitor it. Oh no, the sun comes out. Jeez, I'm missing out. And then we have another look at the BMSs and see if there are any cells going under 3 volts already. but I think we have to go down to about 7 or 8% until this is happening. Okay, see you at 10% again. So, and now we are getting the first alarm on our system here. This is the low state of charge alarm from the smart shunt at 13% state of charge. So we're just confirming this. Then we can go back 13%, discharging 1.3 kilowatts, still going strong. Oh wow, we have several alarms now here on the on the Victron system. So here's the situation. We are down to 6.4%, but still above 48 volts. So that means we are still above 3 volts per cell. Okay, let's have a quick look in the battery, which is maintained by the Overkill system. We've got a deviation of 60 millivolt around. Cell number 2, 3 volts. That is all okay. Quick look in the JK-BMS, 68 millivolt deviation. Cell number 10 is low, discharging with 23 amps. And the Heltec BMS shows us 170 millivolt deviation, but this is just because cell number 15 may have a problem with one of the terminals, because it is at 3.1 volts. That's a bit too high. There's something wrong with the terminals. Okay, I have to check this. But apart from that, everything goes strong. Everything is nice. Cell number 14 here is under 3. I have actually connected the vehicle as well and charged it at the same time to speed things up. Otherwise we would have to wait forever. And it is good to see I can go down to 6% state of charge of my batteries, and I still have over 3 volts in each of the battery cells. Let me throttle down charging here in the vehicle, and we go back. Yeah, see, the voltage is even rising now in the battery banks, because the load is now spread across these 3 battery banks. They are holding the voltage really well. And this was exactly what I wasn't sure about, if I can go actually lower now. So we have around 850, 860 ampere hours of capacity, and we have used 830 accordingly to the Victron shunt, just there. So it says with this load we can go another 46 minutes until we are at 0. But usually I would probably turn off my loads, or would reduce my loads at least at 3 volt of battery voltage now, because this is already now this is at the knee of the curve now. We are going into the steep area of the curve now, and it will drop down very quickly from here on. And we know from our tests we have now only around between 4 and 7% state of charge left, or capacity left in the battery now. And this is what the smart shunt shows us as well here, 5.8. So it seems to be fairly accurate at the moment. But again, I have set my 2 Victron inverters here to shut down at around 40 volts or something. So really push them down. In an emergency situation, I can still access the power here from these batteries, and I'm not worried about that one of them is shutting down because of a low voltage situation. And this is probably what you want to do in an off-grid situation, where you don't have a generator, you don't have grid power to recharge your batteries, you don't have any other power source. And then you need to do this testing as well and see how far you can actually drive down your batteries until the BMS shuts them off, until cells go really low. But what can you do? If you need the power, you need the power, you know. You drive down your battery banks as much as possible to harvest all the energy you can get from your battery cells. But in a hybrid setup installation where you have grid power or a generator, I probably would stop discharging here at 3 volts per cell, around 48 volt. This is my lowest point I would go to, and then turn on the charger or the generator and recharge the battery slowly then. But yeah, here in this test we want to go lower. We want to see what happens when single battery banks actually shutting off now, and then see what is happening to the remaining battery banks. How far can we go down? So I have just removed the cover here of our bottom shelf battery, and measured the voltage of our cell number 15, which we have replaced in the last video, and it is in fact at you can see it 3.15, 3.16 volts still, while the other ones are below 3 volts now, just below. So it is actually our battery number 15 which is very high in state of charge. I probably should have tested this before I replaced it, but that's just what it is now. We will see the next time when we fully charge the battery in a couple of months. This battery number 15 will definitely peak here, and then we have to use our light bulbs or something to discharge it, because the Heltec BMS is certainly not capable of balancing this cell out. Oh, the inverter has just shut down. I don't even know why. Let's check some BMSs here. Okay, bottom is our Heltec BMS. Yeah, discharge disconnect it has. Ah, here, cell number 14, 2.5 volts. Okay, this one has shut down. Let's check the JK-BMS. Yeah, cell number 10, 2.5 volts. Cell under protection. This is turned off. And this is the Overkill solar at the top. Has shut down. 2.6 volts, cell number 2. So all 3 BMSs have shut down, and I have missed it. I have completely missed it. Oh, now it turns back on. It's probably not. Yeah, and then it turns off again. Okay, I'll just turn this off manually here for a moment, so it doesn't do the stop-start all the time. I was just preparing all the mobile phones again to record everything, and now it has already occurred. Okay, we are definitely at 44 volts battery voltage of all 3 battery banks, and this is how far I can go down. So this was probably, I have no idea, because the Raspi is off as well. I wanted to shut down the Raspi before everything happened here. I said better do a secure shutdown of the system and then just work with the BMSs and see what's going on, but something happened. I think we've got power again. I've got a blue light here. It's not the JK-BMS though. The Overkill is still off. Ah, here, the Heltec BMS has turned on again. That is very quick, because the lowest cell is still at 2.55 volts. Now we don't have access to the Raspi because all my network has shut down now. Everything is shut off at the moment, but we can still see the last snapshot here in the browser. So it was at 3% state of charge when everything shut down at 43.3 volts, and we had 2 kilowatts of power still connected to the whole system. So 3%, this is how far I can go down. That's good to know. So if I shut everything down at 5%, I'm still fine, and I'm in control when I want to shut down the system. So you need to know your lower threshold as well, and this is at 3% state of charge or 43 volts. This is when the BMSs are starting to shut down. Cool, very cool. So everything worked out. If I am not at home or something and something happens with the battery, there's no charge coming in, when we've got load on the system, they will all shut down safely. Take the banks offline one after another, and it actually looked like this all happened quite in a short amount of time. It is only the Heltec BMS which has turned on again, which allows us to actually charge our devices here. Okay, let me recharge the batteries just a tiny bit, and then we do it again and see in which order they actually shut down and how it looks like. Okay, so we are back online now and charging with 1200 watts. So probably give this maybe half an hour or so, and then we do the test again. And then I'm prepared with all my devices and all the recording, and we can see which one shuts down first and why, and how the others react. That was the main purpose. Damn it. So I have now connected our light bulbs here to cell number 15 to get this down a bit, because all the other cells are at 2.8 volts and this one is still at 3.1. So I'm discharging this one, so it is roughly in the same ballpark as the other ones then, because we are now in the steeper area of the curve now, discharge curve, And we can actually compare state of charge and voltage now a bit, because yeah, it is in the steeper area of the curve now. So if I get this one down to 2.7, 2.8 volts as well as the other ones, it should be in the same state of charge then as the other ones. Saves me all the trouble once we fully charge the batteries again, and this one is peaking all the time and the BMS is turning off. So I'll do it right now. We have to wait anyway until the batteries are charging up from solar. So let's leave it on for half an hour and see how much we can bring it down. Okay, I think I've got the recording running on all three devices this time. That is running, that is running, this is running. Okay, so I'm still discharging cell number 15 here on the BMS on the right, which is our Heltec BMS in the bottom shelf. Cell number 15 is the new one we've just replaced, and it is still high. High state of charge. Okay, let's turn on the pull pump again. So this should turn on and ramp up in just a second. There we go. This is around 1 kilowatts now from all three battery banks. We have just recharged over 48 volts. So 3 volts per cell. We can see around 3 volts, and now we are going to discharge the battery again until it totally shuts off. Before we do that, I'm going into the remote console and we are actually shutting down the Raspberry. Don't want to have a corrupt database on it again. Shut down. Bang. Shutting down. Bye bye. Okay, Raspberry is off and we can just let things happen as they are. And now we have to wait. Shouldn't take too long. We are under 3 volts with most of the cells. So we are going into the steep area of the curve, down the cliff. I was really surprised that the BMSs have shut down so quickly one after another. So okay, I have now started the screen recording again because we're getting close. Some of the cells are at 2.75 volts. I'm lying 2.78 volts. We are still discharging here with around 8 amps from the Overkill battery at the top, 5 in the middle, and about 6, 7 in the bottom shelf with the Heltec BMS. You can see the deviation, 150, the top 160, 136. So that's not too bad at this low state of charge. And all three BMSs are showing, well, 0 or 1% state of charge of the battery remaining capacity. So that's good. Okay, so we are now very, very close. 2.55 volts in cell number 2 of the Overkill Solar BMS, and 2.58 in the JK-BMS, and 2.58 in the Heltec BMS at the bottom. So this is a race again, and I'm really, really surprised that these BMSs are so close together at such a low state of charge. That is unbelievable. I was really thinking it is one BMS or one battery which is shutting off first, and then it takes maybe half an hour or so until the next one shuts off, and then the third one comes close to that. But it looks like they are so close together. That is insane. I would have not expected that. So it will be really like a tuck, tuck, tuck shutdown very quickly. The Overkill at the top will shut down first, 2.51 we have, and then we can see the discharge, or the discharge button will turn off. And then it will be up to the Heltec and JK-BMS to supply the power to our loads. There you go. It has turned off. The Overkill Solar has turned off. You can see the discharge button is already off, so this whole battery bank is offline. And we are still, and now the JK-BMS has turned off. Protection under voltage. And we should see, there we go. I could hear the inverter. And there's the Heltec BMS turning off as well. So we are offline again. That's how quickly it goes. Wow. Okay, and there we have it, guys. Yeah, not as spectacular as I thought it would be, but still impressive that everything works. So we basically have this battery turning off first, then the JK-BMS, and then this battery here at the bottom. But this is just a random situation. This has nothing to do with this one. Is the top one is closer to our load than the other ones. Yeah, and as I said before, I find this very important to know what actually happens at a low voltage disconnect with your battery bank. Is everything safe? Is everything shutting down as it's supposed to be? Are the inverters shutting down? Are there any problems occurring in your battery banks? It just turned back on. Especially here with different battery bank, and it turned back off. Especially here with different capacities in the battery banks and 3 different BMSs here. I think I can be very happy with the design, implementation and installation of this battery shelf here. Everything works just quite as we planned it, as we designed it. And now we have done the high voltage disconnect test and also the low voltage disconnect test. And probably in summertime, when we can quickly recharge these 3 battery banks here, we want to do a full capacity test on all 3 batteries as well. So we can dump all this energy into the vehicle then, for example. I need to drive down the car probably to under 10% or so. Otherwise, there's not enough space in the car's battery to fully... No, it should be fine. We still have some losses, which could be around 20% or so from discharging this battery here to charging the vehicle. But we will certainly do a full capacity test here and see how much kilowatt hours we get actually out of this battery bank here. Okay guys, so far this video from today. I hope you enjoyed it. I hope you learned something. I hope I took away some concerns from some of you saying what will happen if I parallel these battery banks, what happens in the low disconnect, what happens when I fully charge them. This has all now been tested here and confirmed. It is all working fine. Guys, until the next video, you stay charged, stay safe, and thanks a lot for watching here. I should turn on the solar charge controllers again now to recharge the battery. It sits on 3% only.